Hello and welcome to TE Connectivity's Crompton Instruments Integra 1222 Self-Powered Digital Metering System Setup Guide. Out of the box, the Integra Digital Metering System, 2 wire sealable terminal covers, terminal blocks for voltage, current, Modbus communications and pulsed outputs, and a setup and operations guide. If you've purchased the separately available IP65 protection kit, you'll also have 2 plastic spring clips and a neoprene panel gasket. Firstly, if you have the kit for IP65, you'll want to apply the panel gasket first. The panel gasket has 3 single pips on 3 sides, but on one side it has 2 pips to identify the place of installation on the product. If you look at the product and find the top, there's the 2 holes for the 2 pips of the panel gasket, which identifies the orientation of the gasket. To fit the gasket, simply put the gasket into the correct position with the 2 pips facing the top, and start to apply the gasket over the case of the Integra 1222. Feed the panel gasket all the way around the sides and lift the edges up over the edges of the product. Feel your way around the product and press the panel gasket firmly into place on all sides. The product is now ready to be installed into the panel. The next step in installation is to fit the product into the panel, into a standard 96 by 96 mm cutout. Integra 1222 snaps into place using its integral snap mounting clips. Now Integra is fixed into the panel along with the gasket, it's time to fix the spring mounted clips to give it that extra IP65 protection. The spring mounted clips are applied to the side of the product and pushed forward with a click. Try not to press these too hard or the clip may break, so just press in enough so that it feels secure. And then repeat this on the other side of the product, applying the second spring mounted bracket in the same way. Integra 1222 is now fully secured to the panel and IP65 protected. Next, we're going to fit the terminal blocks for voltage, current, Modbus and pulsed outputs. The first terminal block is the current terminal block, which fits into the top of the product. For safety reasons, we advise screwing the current terminal block securely into place to avoid accidental removal of the current connection. Once the current terminal block is fixed into place, apply the Modbus communications terminal block into its socket. As this is the self-powered model, it comes with 2 pulsed relays as standard, and this is the block for the pulsed relays. Applied here. And finally, the voltage terminal block fits on the bottom of the product like so. Next, we're going to apply the wire sealable terminal covers. As you can see, there's 2 pips, one either side of the terminal cover, which slide into the slots on the top. Simply press forward and shut down the terminal cover. Repeat this process for the bottom terminal cover, which slides into place exactly the same. That completes the hardware setup for the Integra 1222 self-powered unit. Now we're going to view the measured parameters of the Integra 1222. On power up, the Integra checks the display segments, displays the latest firmware revision installed, and indicates that it's passed an internal self-check. The top button selects the power, voltage, current and energy of the active system. The first screen shows phase 1, so we're going to press the top button once more to show phase 2, and then phase 3, power, voltage and current. Another press of the top button returns us to the first screen. Now if we press the VA button, it's going to show phase 1, 2 and 3 voltage, line to neutral and line to line, the current on all phases and neutral, and the total harmonic distortion of the voltage all phases, and the total harmonic distortion of the current on all phases in a percentage. This screen showing the phase sequence of the voltage and the current. A press of the MDPF button shows us the power factor and frequency of the system, the power factor per phase, the maximum demand current per phase, and the active power, reactive power and apparent power of the system. Escaping from that screen, a press of the P button will show us the active power on all phases, reactive power on all phases, and the apparent power on all phases. The system powers are shown on this screen here. A press of the E button shows us the imported kilowatt hours, kVAR hours, export kVAR hours, and the total kilowatt hours and the total kVAR hours. Whatever you leave this setting on is the setting that Integra will keep. To enter the setup menu, press the VA and P buttons together and the Integra will ask for its password. Out of the box, this password is set as 4 zeros. Once into the setup screens, the first thing we can change is the system type. This is the self-powered model, so the available system types are 3-phase 4-wire or 1-phase 2-wire, a single-phase system. To select the system type, hold down the E button for 2 seconds until you see the word set. The system is now set as 3-phase 4-wire. Press the VA button to escape out of the system type and arrow up to the change password screen. Pressing E will make the characters flash and you are able to change the password to any 4-digit number between 4 zeros and 9999. Change the first character using the up and down arrows, and a press of the E button moves on to the subsequent characters, which can then be changed in turn. In this example, I'm setting the password as 1000 and holding E until Integra says set. Press the VA screen to escape and arrow down, down again, and this is the primary voltage setup screen. If you're not using a voltage transformer, simply leave this voltage as 277. If you are using a voltage transformer, this is where you can enter the primary voltage of that transformer. We're going to set our primary transformer in kilovolts. So for example, if we're using a 132 kV voltage transformer, Enter the numbers 1, press E to move on to the second character, change the second digit down to 3, the third character to 2, and press E and E once more to select 1320. Now you can see that we're saying 1.32 kV is not correct, so we need to change that to 132 and get the decimal point in the right place. So we hold down E, arrow up twice to get the decimal point in the right place, press the E button consecutive times until the screen displays 132 kV and says set. Press VA to escape from the primary voltage and arrow down to the secondary voltage selection. If, for example, your secondary voltage was 140 volts, repeat the same sequence as the primary setting and set the secondary voltage. Now we've set our voltage transformer ratio, press VA to escape this screen and arrow down to the primary current. This is where we set the maximum primary current that can be monitored according to the CT in use. In this example, I'm going to set our primary CT to 1000 amps. And just hold E to set the primary at 1000. Now to set the secondary of the CT, you press the VA button, down to select the CT secondary, holding E. It's currently set to 5 amps and we can switch between 5 or 1 amps. In this example I'm going to set the secondary at 5 amps by holding the E button until set is displayed. A press of the VA button takes us to our next setup option, which is current transformer direction. This relates to the direction of the primary conductor, and the available options are forward or reversed, and this needs to be repeated as necessary for each CT. This is a useful feature in the event of any wiring errors, and being unable to get easily to the back of the product to correct the error, you can simply change the direction of current to reverse to correct the wiring error in the software. If there's no wiring errors in the system, then there's no need to change this setting, but a useful feature nonetheless, especially if the CT secondary terminals have been wired the wrong way round or the input to the product itself is wired. If there are wiring errors on more than one CT, simply arrow through CT2, CT3 and make the necessary changes in the same way before pressing VA to escape. And arrow down to our next settable feature, which is demand integration time. This sets the period in minutes in which the current and power readings are integrated for maximum demand measurement. The available options are 8, 15, 20, 30 and 60 minutes. In this example, we're going to set our demand integration time at 30. Having set that, press the VA button to move to the next selection, which is the energy units. This is to set the energy units used by the meter, and the available options are kilowatts and megawatts. The available units may be restricted by Integra depending on the voltage transformer and current transformer ratios programmed. The next setting is the energy floor on or off. This is to prevent creep caused by electrical noise being accumulated as energy. In the event of this being turned on, the product will employ a low power limit below which the energy will not be accumulated in the meter. We're going to set ours off at the current time. The next set of features is the reset menus. The meter provides a function to reset the maximum demand of current and power accumulated, and we've reset that there. And the meter will also allow for resetting energy and also demand and energy together. So if we arrow down to reset all and then arrow down to energy, we can flick through the necessary settings. If we leave it on energy and then hold E, we've now reset all the accumulated energy but left the demands in place. If we want to reset both the demands and the energy accumulated, we simply hold down E on all, and all demands and energy accumulated is reset. The next settable features is the communications. So to go into the communications setting, press the E button, and the first setting we're presented with is the baud rate of our communications. The available options are 4800, 9600, 19200 or 38.4 kilobits per second. We'll set ours at 9600. Escape back to this screen, hold the E button to go back in, press the arrow down. Now we can set our parity. Available options are none, even or odd. We'll set ours at none by pressing the E button and escape back out with the VA button to then go back into the communications and arrow down to our next communication setting, which is stop bits. Available options on stop bits are 1 or 2. We'll hold E to save this as 1 on this occasion. Now if we escape out by pressing the VA button, go back into our communications settings, we can set the Modbus node address of the product. At the moment it's set at 247. So we're going to use the arrow up and down buttons and the E button in turn to select our address. I'm going to set this particular meter as address number 17 by holding the E button till it says set. Press the VA button to escape and arrow down to our next settable feature, which is the relay output. The relay output can be set as off or to pulse on import watt hours, export watt hours, import var hours or export var hours. We'll set ours to import watt hours. If we press the VA button and arrow down to the next setting for pulse rate, we can select a pulse rate of 1 pulse per watt, 10 watts, 100 watts, 1000 watts, 10 kilowatt hours, 100 kilowatt hours or 1000 kilowatt hours. The reason we can't see all those options here is because the system set is a high power system, 132 kV and 1000 amps. Our next setting is for the pulse duration, and the available options are either 200, 100 or 60 milliseconds. We'll set ours at 100 milliseconds. And we can now review all of our pulse relay settings by arrowing down through the settings that we've put into place and move on to our next setting. Our next setting is the backlight timeout setting. This is the programmable time that the backlight will remain on for before it's extinguished. The available options are 5, 10, 30 or 60 minutes. We'll set ours at 10 minutes. Press the VA button to escape. Arrow down to the test. Test to check the display segments. Available options are display on, and you can see that Integra will check all of its display segments are working correctly. If we select display toggle, this is where half of the segments will light up in one screen and the rest in another, and the meter will continuously switch between the two for visual checks. If we escape using the VA button and arrow down to our next feature, this is the product software, and this details the product code and firmware version installed. We can arrow down to display the default frequency, which can be changed between 50 and 60 Hz. This brings us to the end of our setup, and if we hold the escape button for 2 seconds, you can see we're returned to the main screen of the Integra 1222, which is displaying the system power, voltage and current. You may notice there is a exclamation mark in a triangle at the bottom left hand side, and that would indicate that we have our low power threshold turned off. If you want to remove this, you'll need to go and turn the low power energy floor on by going back into the setup menu and navigating to the energy floor setting, and hold E to enter. You can see it's off at the moment. We're going to hold E and turn the energy floor on, and this will prevent any creep caused by electrical noise. Now that's set, if we hold down the escape button for 2 seconds, return to our main screen, you can see that the warning triangle has now disappeared from the display, which indicates the energy floor is working correctly. That concludes the hardware and setup guide for the Crompton Instruments 1222 self-powered unit. For more information, please visit www.crompton-instruments.com, or you can contact us by emailing ci-technical@te.com.